Hi, I'm Phil. I lived in San Francisco for a couple of years, working 2 blocks north of here at the old Zencoder office for Brightcove. I'm moved over to Mux recently. This is a presentation that I've wanted to write for ages, but haven't really gotten around to it. It was actually written for the FOSDEM conference in Brussels, which is effectively the same as OSCON is out here. So when I started putting this together, I put a subtitle of reaching as many viewers as possible using only libre video technologies. Now, if I was writing this again, I'd write differently. I'd say reaching as many web viewers as possible with the best user experience possible using only the same libre video technologies. Now, what this means to me is just because we're using libre technologies, free technologies, we shouldn't be delivering a premium, high-quality end-user experience. That's still an important thing. Now, obviously, the next question is, well, what do you mean by libre video technology? Because everyone has an opinion on that. I certainly do. Here's what my opinion is. So I want to avoid patent-encumbered technologies. That one's fairly obvious, hopefully. But also preferring technologies that are developed in the open. So I like working on technologies where I can become part of the community, where I can contribute back, where things can improve, and where there's groups of people working together. That's kind of why groups like this exist, right? We like working together, learning from each other, and improving things. Now, some people might say, like, nobody wants that. Who really wants that? So actually, Wikipedia wants this pretty badly. I don't know, has anyone here uploaded a video to Wikipedia? No? Oh, one person. Hey, 2 people, actually. Has anyone uploaded a video to YouTube? Okay, more. Good. Well, that's reassuring. If you try and upload a video to Wikipedia, it's really interesting. You actually have to go enable an uploader in your user settings. You have to have an account. You don't have to have an account to edit articles, but you do if you want to go and upload a video. And you can only upload in what's referred to as a free file format, which to them says WebM and Ogg. Now, I have many nits about that statement, about codecs. I'm pretty sure I can give you some certain codecs in a WebM that you don't really want, which is quite different. And there's this great article called Help Converting Video, which is effectively a tutorial on how to get a VP8 file inside a WebM out of other services. So included in here is go upload your video to Vimeo and download it from Vimeo and put that into Wikipedia is one of the steps in here. There is a video tutorial, however, which is hosted on YouTube. It's awkward. I'm not trying to throw shade on Wikipedia. Obviously, they do some great work, but the video experience is not there yet, and they are working on that, to be fair. When I think about the components of a playback chain, I'm thinking about things like encoders, codecs, containers, delivery technologies, and a player. I'm not really going to talk about encoders. I don't really think I need to tell you there are some good open source video encoders in the world. One in particular springs to mind, but I'm going to talk about the rest of these. So the big one, really, the main one is obviously codecs. So you'll see this structure slide a few times in this presentation, which is what I consider a libre categorization, what I consider not libre or patent-encumbered tech. So when we look down the codecs, it's pretty much the usual suspects: VP8, VP9, AV1 are all libre software. And for audio codecs, we've got Vorbis and Opus. And for patent encumbered, we're talking about the MPEG technologies for video. I put VVC in here. Isn't everyone impressed? I forgot to put the new one in here, which I've already forgotten the name of. And then for audio, we've obviously got the MPEG AAC, but also the Dolby audio technologies as well. Now, you can pretty quickly get rid of even thinking about using some of these technologies, really. AV1, it's out there, but it's not got the penetration, but we'll come on to AV1 a lot more as this goes on. Now, what's really interesting for me is if you start to think about what you can really use on the web on a daily basis, on the patent-encumbered side, you're pretty quickly down to one combination. You're down to H.264 and AAC. The Dolby technologies, the audio technologies just don't exist in anything that's not a living room device. It's just not there, really. HEVC made a brief appearance in Edge and then got removed again. So VVC basically doesn't exist either. So what I did is I wanted to test this. I wanted to see where I could get this stuff playing. So what I did is I picked the evergreen browsers. So the evergreen browsers are the big four, the four that are actually updated meaningfully, get new specs, things like that, the actual good browsers. I put together a really simple test page. All it does is load a player, load a progressive file in it, and try and play it and see if it plays. Now, what I want to tell you is these are real screen captures. People don't believe me when I say that. They don't believe I went to the effort to do this, but I totally did. These are real captures of little videos that I put in all of the browsers and checked if they played or not. So across that top slice, so we've got Chrome, followed by Firefox, followed by Edge, followed by Safari, the big four evergreen browsers. Top one's AVC, AAC, and an MP4 container. It just plays everywhere, which is basically what we'd expect, right? Now, actually, I was a little surprised. So we've then got VP8 with Vorbis on the next row, and then VP9 with Opus on the row after that. Now, I was impressed that actually those played in the 3 out of 4 of the evergreen browsers, where Safari has basically one of the smallest market shares. So that's actually pretty good. So our real problem here is Safari. If we want to put that into numbers, which I always do, Chrome represents 71% of traffic on desktop. It's pretty good. 10% for Firefox. Safari, 5%. We're missing 5% there. And Edge represents about 4%. So out the box, we've actually got 85% coverage. And that's pretty good as far as I'm concerned. So to be fair, I think AVC, AAC, and an MP4 is going to be 95 or higher on desktop. But you're still within 10% on your first attempt without doing anything clever. I think that's actually pretty good. The problems are obviously Safari and Internet Explorer. I'm not going to really go into Internet Explorer too much, but we'll mention it in passing later. But yeah, so there's our problem, children. But 49% of web traffic is mobile. Now, little detour. This is stat counter from December. I cannot explain that dip and spike in traffic from desktop and mobile, and neither can anyone else on the internet. Nobody has an explanation for why these graphs suddenly went the wrong way and then went back. I haven't looked, I must admit, I haven't looked at January's data, but I don't know why this happened. I assume it's actually an anomaly. I think it's wrong. I really do think it's wrong. But somebody please tell me if you know, because, anyway. So let's take the 3 major mobile browsers. So we've got Chrome on iOS, Safari on iOS, and Chrome on Android as well. This is where things obviously start to not look as good. And again, real screen captures, okay? Totally real screen captures. I got out my Android tablet. I downloaded 6 or 7 crappy apps to claim to record my screen and just serve me ads. Thank you to iOS for having a built-in screen recorder. That would be great if we could get one of those on Android. But obviously, again, AVC, AAC, and an MP4 container just plays. But VP8 and VP9 don't play on any Apple devices, which is basically what we'd expect. Good news is Android just plays. Great, fantastic. But yeah, so we instantly miss out on all Apple devices. So same stats. Unfortunately, basically all that works is Android Chrome. 41% of the market, and that's it. AVC, AAC, MP4, you're talking about over 90%. It's a little less than you'd get on desktop, but it's still pretty substantial. 37% of iOS experiences just don't work. Anyone with an iPhone would not get your video. And the real annoying thing is, of course, it being an iPhone, even when you click into a link from Slack that loads a web page, anything that's got a web view in it is just using the same technology, so it's not going to play there either. So what can we do about that? Polyfills are really the only solution out there right now. So we can use polyfills to render unsupported codecs just by using Canvas and web audio and doing the decoding in software. OGVGS is the best one of these, in my opinion. And it's not just because my friends made it. It does have some drawbacks. It's obviously CPU heavy. The good news is OGVGS, you can use WebAssembly. It works really well if your browser supports it. It's a non-native experience, so you end up spending time having to try and reskin things to match a native experience. And the big one is, I'll talk about this more, but there's no media source extensions, obviously, no source buffers, which means, well, we'll get onto what it means, but it's a bit of a pain. So then I went and updated my page with all the dodgy, broken experiences and captured it all again, and it totally plays. And actually, I'm not sure if you can see it on projector, but certainly on a good screen, you can totally see there's actually some color rendering differences between these captures, which is really interesting. But it totally plays. So this is using OGVJS to polyfill on all those devices, and quite happily plays in decent resolution on a good footprint of devices. It's so good, in fact, this is what Wikipedia actually does. So since 2015, it renders all unsupported codecs on IE and Edge. The IE thing's a little bit alive there, but also Safari. So that's pretty great. Containers, I don't need to really talk too much about containers. Hopefully it's fairly obvious. Generally, codecs and containers come as pairs. So on the libre side, we'd have things like Matroska and WebN containing VP8, VP9, AV1, Opus 4bis, etc., that sort of thing. And I have corrected this slide since FOSDEM when somebody pointed out very politely that I was wrong. I totally was wrong. MP4, ISO BMFF, obviously still pan encumbered for now, but MPEG-2 transport streams have expired because they were part of the MPEG-2 spec, which expired in February 2018. So technically, MPEG transport streams are free-for-all. You can do whatever you want with them, and probably not get sued. But what we'd expect, yeah, obviously to see all the MPEG codecs being packaged up in MP4 these days, unless you're big into older Apple devices. Netflix have a spec for VP9 in ISO BMFF they use, not used widely outside of Netflix. Now, delivery technologies. So delivery technologies are really important. So I mean, what's wrong with just a progressive download WebM file? Viewers' bandwidth changes, right? Great example. Bandwidth's changing all the time. You could totally encode at 1 megabit, give it to everyone. Some users would get a buffering, but other users are going to sacrifice as well. We want to reach as many users with a great experience as possible. And in order to do that, we've got to encode multiple bit rates so we can adapt between them. So obviously, it's adaptive bit rate. Probably all know what it is. Multiple bit rates, multiple resolutions, switching between them based on your throughput and segmented output. So pretty common technologies. Now, obviously, you probably mostly know, but big ones are HLS, HTTP live streaming, M38, your manifest file, different manifests for the list of renditions and also the actual rendition content, and Dash, dynamic adaptive streaming over HTTP. It's an XML file, single manifest for everything. You notice I didn't put these in the patent encumbered and libre columns because here's what I would describe it as. I wouldn't call Apple's HLS libre. It's Apple's. It's developed in a closed environment, pretty much by Roger Pantos. We know that. It's something we don't get to give feedback on. There is an IETF RFC spec for it, but that's really only there to encourage OTT manufacturers to build devices that can play HLS reliably. And Dash is an MPEG technology. It's an XML file, and it's got a patent pool. So probably not libre, as far as I'm concerned. So, we don't actually have a libre ABR technology. If you know me well, you might know where I'm going with this. What can we do about that? So, first of all, there you go. Yeah. Maybe I should have made these pop in separately. We could just use HLS. We could totally say, screw it, we're going to use HLS. It's not an open standard, but it'll work. LHLS is being developed on top of HLS. It's going to be an extension, right? We don't expect, well, maybe we expect Apple to go back and put that into the spec, but I wouldn't hold my breath on that. Now, I've never seen HLS with WebM, VP8, segmented files in there. Unlikely to be added to the specification, but it could totally be done. Or we create a new open ABR standard. So moving pictures amateurs group, simple adaptive streaming over HTTP, MPAG SASH for short. Now, the idea was be simple, JSON, browser friendly, blah, 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 blah. There is an XKCD that explains why this is a terrible idea, and we should not do this. But I came up with SASH alongside John Dahl. I think John's actually left now, 4 years ago on a hack week with some beer, I must admit. And we didn't touch it for 4 years. We kind of just had it as a joke, and it was still there. But 2019, SASH lives, as far as I'm concerned. So We're actually going to move SASH to be the first demuxed open source project. We've talked about a lot in Video Dev Slack. It's got its own room now. Isn't that exciting? It took me all of 5 seconds to create, and then I named it wrong as well. And we've started working on a V2 prototype. Because honestly, 4 years ago, I didn't know stuff I knew now. And now I know things like discontinuities are really, really, really important. So people want advertising models that actually work. And people like timelines. People like timelines a lot, particularly when it comes to discontinuities, because people don't like multi-periods. I definitely don't like multi-periods. So I don't know how well this actually shows. It actually shows passably. That's good. Here's what SASH 2 might look like. So a couple of minor changes. Major changes here are that we've broken out video and audio groupings separately because it's way easier when you're parsing the manifest. It makes life so much easier on the client. We've got rid of the idea of using MIME types to describe media containers, because that didn't make any sense to me either, so we've now changed it just to a container description. And other than that, it pretty much looks like it looked last time. One of the big differences from Dash is obviously that SASH uses an end number rather than doing a lot of computation around segment size and that sort of thing, so it allows you a bit more flexibility there. It also uses all of one way to describe durations, which is seconds as a float, as opposed to the several that Dash uses as an example. Now, here's what we've been thinking about most recently is what timelines and discontinuities would look like. As you can see, it's pretty much taking bits of HLS, bits of Dash, and putting a place in to signal a discontinuity on a segment. And also, we added a relative media mode into here as well. But it's a thought experiment. It's obviously coming along now, but I think it's way more relevant than it ever has been. Now we're actually getting to a place where we might actually have codec support for libre technologies. We need, in my opinion, an adaptive bitrate technology that works with that. But also, unfortunately, if we make an ABR standard, we need player support for that ABR standard. Bit of a headache, but a necessity. But also, polyfills need source buffer-like APIs, because just the fact we have this libre technology, we're still going to need these adaptive bitrate technologies, but we're also going to still need polyfills for a while. Certainly, probably even longer than we think we're going to need them. So we should, if we want to actually give an adaptive bitrate technology, we need a source buffer interface where we can switch between different inputs when we need to. Really quick mention of players. I don't want to spend a lot of time on players. There are open source players. So there's quite a few of them. These are, and I talked about this at FOSDEM, I think Video.js and HLS.js represent really interesting things because one is kind of a full framework, very high level, and HLS.js is a relatively low level framework. It's pretty much just adding HLS playback. Now, the good news is both of these we could totally go and add HLS extensions into. And Video.js, if we wanted to go write a tech for SASH, that would be really easy as well. That would not be a problematic thing for us to actually do. They're both licensed sensibly, totally things we could use to build a Libre video stack. So if we take all this and put it together, like what can we do today? VP9, Vorbis in WebM, Video.js with the OGV.js polyfill module, 90% desktop at least. Actually works in IE as well, so it's actually a bit better than 90%, might be up to 96, 97% maybe, and about 80% mobile. So even out the box, what I think we're getting to here is within 10%, maybe 5% of native experiences, which is pretty good. But next to deliver that premium experience, that great user experience, we've got to do ABR, which means we have to either develop SASH or come up with something involving HLS. And we've got to go and update OGV.js with an ABR capability, but we've already talked about that with OGV.js and very much desperate to do that. Now, when I put the proposal in for FOSDEM, I actually said I was going to talk about AV1 and then realized about 20 minutes before the talk I hadn't got a single mention of AV1 other than crossing it out 3 slides in at the beginning. So, does AV1 help? Maybe, hopefully. Chrome, Firefox already support AV1. That was 2 days, I think, before FOSDEM was. Apple and Microsoft are in AOM. Microsoft has an AV1 decoder. You can go install it from the App Store. It works in Edge. So far, so good. We're actually at 3 out of 4 straight away. Apple are in AOM. they haven't announced their intentions. We don't know what Apple are thinking while they're in AOM. They may be there to observe, they may be there to do something else. We don't really know. They also recently announced they're removing VP8 and VP9 support from QuickTime, so that's really unhelpful. Sending mixed messages much. But Apple would actually need an adaptive bitrate standard if they pushed for AV1. They would have to do something. My guess, complete guess, would be AV1 in a fragmented MP4 with HLS. That would be what I would guess Apple would do if they chose to invest in AV1. But I'm also totally willing to be completely wrong on that. I don't see Apple throwing away HLS as a key piece to that. So what they package it up in, my gut instinct is they've sent a lot of signals. Are they still happy to work with fragmented MP4? It's only a recent change to Apple anyway to support it in any way, shape, or form. So I'd expect continuation of that, really. So all of this code is open source. All those lovely little player demos I showed you, all open source. You can click the links and they totally work. SASH, we are moving it, but you can totally go and have a look at what the current version is on the SF Video SASH project. And also, for those of you who haven't seen it, I have a players project, which, oh, there you go, which is a cool way to test video players. And this is part of how I was experimenting with other playback technologies as well. You can pick a video player, you can click load demo manifest, and it's going to go off and play Big Book Bunny, obviously, because it's the only video file in the world. It even has a light theme and a dark theme. Look at that. That really, really hurts. It's the most important thing to developers, I know. And there's also a bunch of commercial players in there. So if you want to take a look if your files actually work on a bunch of the commercial player platforms, you can go through and try that. You know, take your pick, and it will happily go off and play the same set of sort of manifests. So it's good fun. If you do develop a player, send pull requests, add your player. Or if there's ones that you don't like, just add them in. Oh yeah, it's not good for the battery. It's absolutely not good for battery. You are also semi-limited on resolutions and bit rates. You know, don't expect to throw in a 4K file and for it to play. It can suddenly do 720p 30 quite happily on like my middling of a range iPad. Yeah, it does drain the battery pretty quickly. It does get warm. It totris does. Someone actually asked me at FOSDEM, well, why are you actually saying use VP9 and Orbis rather than using VP8? Because you actually get the same market penetration. Now, I guess that's a trade-off for each individual person, right? Would you prefer to save some bandwidth costs for yourself and some storage costs for yourself? Or would you prefer to not burn your users' batteries as much? VP8 is computationally a good chunk easier on the decoder inside OGVGS. There is actually also an AV1 decoder in OGVGS as well. That doesn't really get far, funnily enough, but it totally exists.